Well, as it turns out, if you combine apples and apples, then you, as it turns out, can figure out how many apples you have. But once you start combining apples and bananas, you can't say, well, if I have 3 apples and 4 bananas, I have 7 apples. You certainly wouldn't be able to say you have 7 bananas. But you could say you have 7 pieces of fruit. Okay? All depends on how you look at it. It's the same way with adding these types of rational numbers with decimals. We have to be comparing the same place values. And with fractions, we need to be comparing the same size pieces, the fractions of something else. Like on this example, place values matters. Alright, so on this one, right up in here, 3.2 plus 4.01 equals 4.3. I mean, that's false. I mean, I don't even really know how they got 4.3. But here's a common mistake, though, right? We see 4.01 plus 3.2, and then we get, I don't know, 7.3. What this means usually is that they've added the 1 and the 2 right there, but they're not in the same place value, so we can't do that. So be very careful. It's recommended that you guys line these up by place value ones, tenths, and hundredths. If you need to put a 0 there, you can then use that one, okay? And of course we can see that the actual answer should be 7.21. Replace that. I'm going to do number 3 because it should work a little bit more better conceptually. So let's take a look at these. Bam, right here. We got 5/3 minus 3/4. So now let's look at those pans of brownies. So the 5/3 is what we have. So we have to look at these 2 pans of brownies, which I hope you guys like brownies, right? Yeah. Brownies are good. Yeah. Well, let's cut these up into thirds so that now each pan represents a third of the pan. And how many of these thirds do we have? We got 5 of them. That's what that's telling us, which means that this piece right here does not exist. Right? Someone already ate that piece. It wasn't me because it was too small. All right. Well, this is saying that we need to subtract 3/4. So what this is not saying is that, well, we're going to eat three pieces, 1, 2, 3, and then we've only got 2 pieces left. No, that is not what this is saying. What this is saying is that someone ate 3/4 of a pan, which is, more of my size portions. So here's what we're going to do, is we need to be comparing the same size pieces so that we can just eat or see how many of those pieces have been eaten. So each of the pans has been cut up into thirds. Now I'm going to cut them into fourths horizontally like these. Okay, that way we can see how much a fourth is up in here. And now each pan has 12 pieces. This pan, of course, only has 8 of the pieces, 8 of the 12ths. And then up in here, there's 12 pieces, right? Well, 3/4. 3/4 of a pan. So we're looking at the fourths. That represents 3 of the 12ths. That's a fourth. This fourth right here would represent 3/12. And then this row right here would represent 3 pieces out of the 12. Those are the pieces that someone's eating. So someone ate these 3 pieces. Someone ate these 3 pieces. And someone ate these 3 pieces. So the question for this is, how many pieces is left? Well, we got 1, 2, 3, and then these 8 right here. 3 and 8 gives us 11. 11 pieces. How big are the pieces? They're 12th size pieces. So that would be the answer to this problem. 5/3 minus 3/4. Here's the thing is, this needs to help you understand why we need common denominators. You're right, we do need common denominators, but only. When is it that we only need common denominators?
When you're adding.
Marley, right?
Yeah.
Addition and subtraction, that's the only time. The only time we need common denominators. Do we need common denominators when we multiply? No, we do not. Do we need common denominators when we divide? No, we do not. Okay. So, you guys said this is confusing. What is confusing about it? So it's the colors. The colors are confusing. I like the colors. I think it's pretty. And I like the pictures because I like to draw them.
So we can just convert it into 12ths instead of like taking it.
Yes, but again, you can do that, and that's what we're going to do from now on. But I just needed an example to show you guys what the heck is going on right here. Because if you guys can understand what is actually happening, you'll be more prepared to do this kind of stuff in the future instead of memorizing all the rules like, oh, we need common denominators or we don't. Whatever. So, we won't use the pan, the brownie example on these. All right, good luck.
Okay, so 3 times 2 is 6, and that would be the bottom number. So 6, and then 6. And then you times 2 by 2 because you have to do that, and that's 4. And then you do 3 times 3, which is 9. And that would be negative. So then you would subtract that. That would be
There you go.
okay. So then that'd be Could you do that? Could you do that?
Yeah, sure. You want some help?
Yes. So
All right.
could you just do?
Oh wait, no.
Could you do?
Who would like to help Smith
Yeah, I know.
do these?
So would you do?
All right.
do
Someone
negative
help him.
5?
Someone tell him.
Okay, so Smith, you're on the right track.
Yeah.
If there's like 2 symbols, you just add, remember, from the big plus sign. So it's actually
yeah.
4 6
Then-
plus 96.
Oh yeah. So how do I?
Just make it
You got it? Yeah, just keep writing. You're good.
Okay.
There you go.
So then that would be 13 over 6, right?
What do you think?
It's
6.
6? Is that right, you guys?
Yeah.
Why isn't it 12?
Because the denominator.
Why is it not 12? Well, tell
So
us.
don't add the.
What's your name again?
Isabella.
Isabella, please.
Because
Thanks, man.
the denominator is 6 on both of the numbers, and you're not multiplying. So, yeah.
Bam. Excellent. Yeah, remember, it's kind of like the brownie example. We have the same size pieces, so we can just combine them. And right here, we're dealing with 6 size pieces. Now, someone asked if we should simplify these. No! You can't. What does that mean? That means that if you think that simplifying will change this into a mixed number, wrong! Never again. No more mixed numbers, ever! What would it be? Doesn't matter, because we don't do mixed numbers. Why don't we do mixed numbers? Here we go, let's do it. All right, so you guys gave me some numbers up in count. I'm going to make that 5 a negative, and we're going to add these two together. Bam. All right, here's the problem with mixed numbers. Is if we add these directly, it is highly likely, just understand the probability is very high that you will make a mistake. Why? Because mixed numbers add extra steps, which we hate. All right.
I learned this.
Yeah. No, you are though. Even if you simplify, you got to change it back into a mixed number, which is extra work. So I'm even telling you guys to do less work than you want to do. That's rare for a math teacher, just so you know. So let's look at this circle method stuff. So we got 5 times 12 plus 7. This is changing it into an improper fraction. That would be 67 twelfths. All right, so that's another thing. Some people forget when we change this, keep that negative. Then we're going to add this to 7 times 3 is 21 plus 13. Bam, 34. Thoids. So now what are some other problems that we run into? Well, some people would say, well, negative 67 plus 34. That'd give you 33 over 12 plus 3, bam, 15. Then you simplify this, you get 11 fifths. Yes, this is all very, 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 very bad. Because, remember how we talked about the order of operations stuff? It's like cutting open the patient and then forgetting to put stuff back. Right? Like you remove the kidney because you got to get to the spine maybe. And you just keep the kidney out, you know what I'm saying? So it's bad order. The order's very bad. Or it's like giving them anesthetic, going and eating a sandwich, and then coming in and then doing the operation after they've woken up. That's very bad. See, the order's all out of place. Okay, so doing just what Smith just did, I'm going to have common denominator of 12, so I'm going to multiply both these by 4. Now I got 132 over 12. And over here we got this 67 over 12.
I was just wondering, okay? Stop.
So what we got up in here is the same. This is the same size piece. I know we're not even close to being done. Don't worry. Like I know you guys are frustrated because someone asked a question, so I made up this example. There's more. It's not like, oh, well, we weren't going to do anything from there on. Just take a nap. Yeah, let's finish. We got to finish. All right.
Yes, I understand.
Nice. Nice. Thank you, Jacob. For heaven's sake. It would take a lot less time if you guys just let me finish. So this is a negative 67 plus 132. See the numerators? I'm combining those because I'm comparing the same size parts. So we're looking at 12ths. Negative 67 plus 132.
199.
No. However you did that is way wrong. Never do that ever again. It appears that it's a 5 up in here. And then a 6. Yeah. Is that positive or negative? It is positive. Can this be simplified? Nope. All right, number 5 right here. So that's all I'm going to do for models, by the way. So we'll just use the common denominator thing from now on. Now here's the problem, because some of you guys like these mixed numbers. You think they're so great. This is why they're not so great. One of the main reasons is that when we subtract, it's kind of hard to say, well, I got 0, 3 3/4 minus 1 2/3. Very, very hard to do. All right, so we do have to change this mixed number into an improper fraction. And everyone should know how to do that by now. We got 1 times 3, which is 3, plus 2. That's going to give us a 5. So
It's 50,000.
We're going to keep the denominator thirds. We got 3/4 minus 5/3. All right, so how do we do this? Well, we are subtracting, so we do need common denominators so we have the same size pieces. What denominator should we use?
12.
12, very good. So to get 12, because I do need 12 for both fractions, I've got this 4, I'm going to have to multiply it by 3. But if I only multiply the 4 by 3 and just said, well, this is 3 now, then I've changed the value of the fraction. That's what we don't want to do.
So you have to times that by
We need to multiply the 3 by 3 also. Very good. What this does is it changes the size of the numbers, but not the value of the overall fraction. 3 times 3 is 9. Now we got to do the other one. 3 times 4, so we'll have to multiply 5 by 4 as well. 20. And then, of course, we have the operation, which is minus.
So it's negative 11.
Well, now we have the same size pieces, so we are just dealing with 12ths. Let's take 9 of them and subtract 20 of them.
11.
Well, then we've got, let me get myself a little bit more space. We got 12ths, and we got 9 minus 20, which is negative 11. That is all. All right, yeah, so just to clarify on this, we have that as negative 11 over 12. If you want to just make the whole fraction negative like this, that's fine. But it wouldn't matter if the denominator were negative. It's just kind of weird to talk about negative size pieces of brownies, okay? But all of these could be circled as the answer, and they all mean the same thing. So it just doesn't matter which of the 3 you choose, just choose one of them. But one of them is negative, only one of them, not both. All right, good luck.
Okay, I found the common denominator, 12. And then this was times by 3, so I went 15. And then I went 4 times 3, which is 12, so it's 13. And that's 2.
What?
Good job explaining.
That was good.
I know. That,
Wait.
2 over 12, and I simplified it to 1/6.
All right, okay. All right, valid question. How'd you get 13 again?
I did 4 times 3, and then I added the 1 to it.
Oh, okay. All right. Thank you. So if I'm understanding that right, we got 4 times the 3, then you added this one right account, right?
Yeah.
Now that's only for mixed numbers, okay? So what we got to do, and you're very close on this, so let's get rid of the 13 up in here and all this stuff, okay? Because it is close. Well, what do we got to do just to continue, Ella?
Oh, I was going to say, can I try?
Well, let's do this. Let's finish this one. We'll do another one. What do you got, Christian?
3 goes into 12 4 times, so the numerator would be 4. Because you times 4 by 1.
Very good.
Good.
Yep, we got to do 4 times 1 up in here, which would give us 4. Now, let's not forget the signs, right? That was a negative 15, 12.
You can turn that into a positive.
Yeah, and this one was minus a negative, so if you want, you can make that a big fat plus sign. So we can change this one as well to plus.
And it's a negative. Wait, no.
Well, this is good because now we are comparing the same size pieces, 12ths. And so we're going to just keep that as 12ths. But now we got negative 15 plus 4. Well, it was minus a negative 4, which is why we changed it to plus. So continuing this, we got 12ths still, but now we got to just do negative 15 plus 4. Yeah, Harley, right?
Is it negative 11?
No mixed numbers.
No mixed numbers.
Is it negative 11 twelfths or negative 9?
It appears that it is negative 11 12. So let's make one of these up, and then there's a fraction stuff. We'll do this one with models, and then after that, the models are supposed to help you guys understand what the heck is going on up in here, so that you know why you need common denominators. So, just keep that in mind as we do this. So here's what we'll do. Let's take something that you guys would probably know already, like a fourth. And then let's add maybe a third. So in fraction form, this looks pretty good. I mean, we could certainly do that. So what do we need on this? Well, let's look at what this is actually saying. It's kind of like having a pan of brownies. Did we talk about the pan of brownies? Yeah, right, because we like brownies so much. So it's kind of like having 2 pans of brownies like these. And then up in here, this first pan, bam, we're going to cut into fourths. However, of the fourths, this piece is missing, and this one is missing, and at these, right? So really, we've just got this piece of brownie right here, right? So this would represent 1/4 of that pan of brownies. Well, the other pan we're going to cut into thirds, but we're going to cut these one horizontally, and we'll explain why here in a moment. So this one is cut horizontally, and what do we have in that pan? Bam, we got a third. 1 piece out of the 3 pieces in this pan. Well, right, your mom comes to you and says, hey, you got to combine these 2 together in the pan, and you got to figure out how much there is of a pan. Otherwise, you'll be grounded, and then you will have to eat your vegetables. So this means that we've got these other 2/3, which I'm coloring in yellow or orange, which are empty, right? The only part that exists is the purple. So to combine these, here's what we're going to do. Is I'm going to cut this pan up into thirds horizontally like these. And this other pan I will cut into fourths vertically like these. Well, now we have a different size of pieces. Instead of the top pan being in fourths, it is now in twelfths. And we can count those out, right? I mean, you got 4 up in here, and then this 4, and then this 4 up in here. And so that's 12 pieces. We've got 3 pieces out of 12. The pan down there below is also now been cut into 12 parts, even though 8 of them aren't actually there. But we've cut them so that there's 12 pieces that would fit in there, and we've got 4 of the pieces. Well, if I take those pieces and add them together, I've got 12ths, and how many 12ths do I got? 1, 2, 3, 4, 5, 6, 7, not 8, just 7. I've got 7 pieces that are how big? 12ths. 7 12ths. All right, so number 8 right here, negative 0.5 minus 2/3. This one, you'll need to change that 0.5 to a fraction. Here's why. Because if you change 2/3 to a decimal, huge problems will happen. You'll get 0.6 repeating. You get a lot of 6s, lots of them, okay? And here's what's happening. Here's what's going to happen if you line that up. Negative 0.5, and then this is minus 0.6, but there's lots of 6s, right? Yeah. So I mean, how do you do that? Well, I mean, there are ways.
You just put the little line above it to say.
But right now, there's not really a good way for us to do that. So subtracting like this would be extremely painful. It is not recommended that you do it this way, okay? So I'll finish this one. This one, we need to change the negative 0.5 to a fraction, which is a common decimal enough that you should know the fraction right away. It's a negative 1/2, right? And then we're going to subtract this 2/3 like these. Well, as we've already established, we do need common denominators for this one. 12,
Six.
24,
Six.
18,
Six.
6. Bam. So we are going to have sixths. How do we get 6? Well, we need to multiply this 2 by 3, but the 1 by 3 so we don't change the value of the fraction. 3/6, that's negative. We're going to subtract that. Up and count, this is 3. We're going to have to multiply it by 2 to get 6. 2 times 2 then, the numerator, 4. Well, once again, now that we have common denominators, just sixths.
-1.
I've got -3 minus 4. Still in sixths. What is -3 minus 4? 1. -1. 7. No, come on, you guys, you got to think about it.
-1 because 3 minus 4 is 1.
You're going to start at -3,
It goes back.
and you're going to go left
-7.
4,
So it's -7.
and it would be -7 up and count.
I said -7.
Now here's the problem though, some of you guys are going to want to change that into mixed numbers still. Even after I've stressed this so many times not to, don't. If you put mixed numbers on the test, you will be marked incorrect. Alright, here is how I got that -7. So I'm just focusing up here on the numerator. -3 minus 4. Alright, on the number line, I'm going to start at -3. The minus tell us to go to the left. How far? 1, 2, 3, 4. 4 spaces. That takes us to -7, which is what we have right here. Alright, let's address the 1/2 issue. So that's -0.5. 5 is in the tenths position. So this really is 5/10 and -5/10. And we can simplify this by dividing both the 5 and the 10 by 5. Which would give us -1/2. Christian, go in the hall. Sit in one of the desks over there. Does that answer your question? Were you paying attention?
I understood this one.
What?
I understood this one.
Nice.
I got it.
Nice.
Go back to that though. Would it be an improper fraction even if it was -7? Or is it still, it'd still be more?
Well, it's -7/6 was the final answer there.
Yeah, so it'd still be a normal fraction, would it be improper?
No, that's improper. Because the total value of the -7 is bigger. Meaning we could change it to a mixed number. But we're choosing not to because they are lame. Yeah. Yes?
So on a test, you want to keep the answer like that?
Hmm. And I would avoid decimals. Yes?
Why? Why do you have not proper fractions?
Because as we've already shown with the other problem, when we operate with mixed numbers, it's a lot more work.
I know, but
Oh, so you're trying to make it easier?
Yeah.
It is easier, yeah. Plus, I mean, that's an extra step if you get to this answer, right? Like, well, how many times does 6 go into 7 once? How much is left over? I mean, that's a lot of extra work that we don't really need to do. So, there you go. Good luck.
Oh no, I'm scared. Okay, so the first thing you do is you want to turn these two numbers into the same denominators. So you're going to turn them into 12 because that's the closest thing. And this just turns into a big fat negative, so -12. And then this one would be 16, but you can't forget this is a negative. And then this one is 9, and that equals -25/12. So the answer is -25/12.
Can it be simplified?
No.
because we
No.
hate numbers.
Yeah, very good. Excellent work. Yes. All right, there's something we need to address. There's some fractions that you guys should know by heart. Some decimals that you should be able to change into fractions, and you should know them right away. Some of these include, these ones you could convert 0.5, 0.75, 0.25, maybe 0.1, 0.2, 0.4, 0.6, and 0.8. These ones you could all convert. So it's not like you really need to memorize those fractions. It just makes things really easy. But for the homework that we're doing today, you're going to have to memorize 0.6 repeating. Okay, this one is 2/3. The only other one that's really important for you guys to remember, because right now we haven't learned how to convert these into fractions, is 0.3 repeating, which is 1/3. So what may happen is you may see something like -8.6 repeating, and there'll be some operations on this thing, but you'll need to change this into a fraction, which means first you're going to need the mixed number, which is 8 and 2/3, and then you would change this into an improper fraction in order to operate with it. But really, these all stem from this 0.6 repeating and 0.3 repeating. Be careful, make sure that that line is actually there. Sometimes we assume it is. All right, here we got 7/4 plus negative 0.6 repeating. So just like we went over, you don't want to change that into a fraction. All right, thank you.
So it's 7/4 plus negative 0.6 repeating, but that's equal to 2/3, or negative 2/3, and then 12 is the closest common denominator, so it'd be 7 times 3, which is 21, and negative 2 times 4, which is negative 8, and then you add those, and then 21 plus negative 8 is positive 13 over 12.
Bam. You're not going to change it to a mixed number?
No.
Good. Because you're not supposed to. Good job. He's going to do it anyways. Good luck.
Okay, so first we're gonna turn this into a fraction, so it'd be what they said. Yeah, I don't know if you heard. And then you're gonna just bring down everything so that goes down, and then 7 dot dot dot. Okay, so now we just have this. Okay, so now we have to try to convert it, because to see what is the least common denominator, and these is just going to be 12. So I had a brain fart right there, I couldn't even speak right there. It was funny. Oh, but we're actually adding it, so, yep.
Hey, will you explain how you got that 28 and the 9 right there? Real quick?
So what you do is when you're doing it, you have to do, because you have to both get them to the least common denominator. So you do 3, 6, 9, 12, and then if you use your fingers, you're holding 4, so you do the number times the amount of fingers you hold up, but because I'm holding up 4, it'd be 7 times 4, which is 28. With it, 4, 4, 8, 12, 3 times 3 is 9. And then you, oh crap, what the, like that, so 37. Can we simplify this? No. Am I right? Yeah, I got you that one.
All right. Very good, Mason. Thank you very much.
Yeah, I think I got it wrong.
All right, so what the heck happened? You guys said that he did it wrong. Is that right?
No.
No, it's right?
Oh my I missed one thing.
You just forgot to put the negative.
You guys said he was wrong. Is that right?
Yeah, no.
No, so he is right.
No, yeah, no.
Yes.
Yes.
Wait, so if it's a mixed number but it's a negative fraction, you can't simplify it?
Oh, no. Has nothing to do with whether it's negative or positive. If we can change it to mixed numbers. All right, there was one very tiny thing, only one tiny thing that changed the answer very much.
A lot.
Does anyone see what that is? Tykert. Bam. This negative radical would have made that negative 28. Negative 28 plus old niner. We just need to change that one. What is that, you guys? What would that give us? It'd be negative 19. Negative 28 plus 9 means we'd go on the number line to the right, niner, making that negative 19 twelfths. Bam. And yes, you have to resist the urge to change that into a mixed number. Let's look at why the decimals stink really bad. Besides it's math, you know. All right. So up in here, I'm going to line this up. I got a negative 1.6. Notice there's no bar above that 6 right up in here, so that's counter. And we're going to subtract a negative, so we can even write the plus there, that'd be fine. 1.6, but this one does repeat. So I got lots of 6's up in here. And this one is going to need some zeros up in here. See that? Repeating zeros. Well, where do we start and how do we do this? We got a negative and then we're adding this stuff. So that's going to be a huge pain. It certainly could be a pain. So we're going to ignore it. And we're going to change these into fraction. There you go.
So you change minus 1.6
Over there.
into 1 6/10. Ignore that. And then still go like this. And then 1.6 repeating is 2/3. So it will be 1 2/3. And then 10 and 3 have the same thing as 30. So it's over 30 and 20 over 30. And you change this into a plus sign, and so it will be this.
Yeah, but isn't that a negative?
Negative.
So confused.
Wait.
Sorry.